All right, so this is part 2 of section 1.1. The notes again continue on the same set of notes that you were using for the last video, which was for the intro and 1.1 part 1. So oftentimes we're going to look at two categorical variables and we want to be able to make comparisons on the information from these two variables. And so in order to do this, we'll often use what we call a two-way table, some different types of frequencies, which are going to be proportions or percentages, and then often a segmented bar chart, which will help us display our information. So first and foremost, a two-way table is a table of counts. It could actually also be a table of proportions or percentages that's going to summarize the data on the relationship between two categorical variables for some group of individuals. All right, we'll look at an example of a two-way table and all of these other definitions after we've gone through all of our definitions. So the next thing we have here is what's called a marginal relative frequency. And so a marginal relative frequency is going to be the percent or proportion of individuals that have a specific value for just one of our categorical variables. So you'll notice that your categorical variables are each on a margin. And so when we look at only one of those categorical variables, we would call that the marginal relative frequency. The joint relative frequency is going to give us the percent or proportion of individuals that have a specific value for one categorical variable and a specific value for the other. So you're looking at basically where the two things meet. Their intersection would be your joint relative frequency. Another type of relative frequency we could look at with these two-way tables is what we call a conditional relative frequency. And the conditional relative frequency gives the percent or proportion of individuals that have a specific value for one of our categorical variables for the individuals who share the same value of another categorical variable. The next few definitions are related to different displays that we could create using info from a two-way table. And so the first is what we call a side-by-side bar graph. And so a side-by-side bar graph just basically puts two bars next to each other for each value of a categorical variable. So the next display we will talk about is what's called the segmented bar graph. And in my opinion, this is the one that I use most often when I want to look at relationships between two categorical variables, because it makes that relationship easily visible to me by looking at the segments of the bar chart. And so basically what a segmented bar chart does is it creates the idea of a pie chart, but within a bar. So one bar would measure 100% of whatever that particular variable is, and then you draw little sections or little rectangles in the area of the bar. That would represent the percent of individuals with that particular category. Now, the third of these displays is a new type of display that is just coming into the AP curriculum, and this is called a mosaic plot. And so a mosaic plot is a modified segmented bar graph in which the width of each rectangle is proportional to the number of individuals in the corresponding category. So we'll look at an example of that as we go through lesson 1.1. I won't show you that one on the next page. They're a little bit more complicated to create by hand. So we'll just use them in the questions that are related to mosaic plots from the updated version of the textbook. And like I said, we'll go over that when we do lesson 1.1 in class together. The last thing is the idea of an association. So we would say that there is an association between two quantitative variables or two variables in general if knowing the value of one variable helps us to predict the value of the other. If knowing the value of one variable does not at all help us predict the value of the other, then we would say there is no association. And by looking at our segmented bar graphs, we can get a pretty good idea as to whether or not there is an association between two variables. So we will talk about this obviously more in depth when we do these questions in class. The last thing on these notes right here is just a few things for us to keep in mind, and then we'll jump to the other page and I will give you some examples. So the values of our categorical variables are the labels for their categories. The distribution is the list of the categories and then gives either a count or a percent of the individuals who fall in each category. When we use tables, it's a good idea to check the data for consistency, make sure that the counts all add up, just to make sure that we have the appropriate given total and make sure the percentages add to 100%. When you round, you may not get exactly 100%, so just keep that in mind. It would obviously be called a round off error, and it doesn't indicate that there's a mistake in your work, it's just the effect of rounding. Now, a round off error should not be very large. I would say within plus or minus 1 of 100, so somewhere between 99 and 101. Percents are often more informative than counts, especially when we're comparing two groups of different sizes. If we're looking at one group that has 100 people and the other group has 200, our frequencies, the actual counts, are going to look very different when in reality the proportions may be exactly the same. A segmented bar graph provides a picture of the relationship between two variables, and we do this by using conditional relative frequencies or conditional distributions. And then finally, even a strong association between two categorical variables can be influenced by other variables that happen to be hiding out or lurking in the background. So make sure that when you see a strong association, you understand that it just means that there is the potential that they're very closely related to each other. We can't prove that they actually are with the information in front of us. So let's look at this example that I've got here. This is some info I just made up real quick to give us something to look at. And it's a set of data that's, say, information related to Columbus upperclassmen. So we've got our grade level along one edge and then hair color along the other. So you'll notice that it's broken down into different groups. So if we wanted to talk about the marginal relative frequency, which was one of the terms on the other page, we would be looking at either the marginal relative frequency for grade level or the marginal relative frequency for hair color. So we're focused on just one of these values. So let's say we're talking about grade level. The marginal relative frequency for someone being a junior would be 70 out of the total 140. Same with seniors, 70 out of 140, which of course each of these is half, so 0.5 and 0.5 or 50%. So the marginal relative frequency is directly related to one variable, so either grade level or hair color. Now if we talk about a joint relative frequency, we're basically looking at something together, something joined together. So it could be a junior and brunette. So junior and brunette, the intersection is this 20 here out of the 140. Okay, so joined together. The other relative frequency that we mentioned on the previous page was a conditional relative frequency. Let me move this out of the way. So for a conditional relative frequency, there has to be some condition that's being met. So given the student is a senior, what's the probability of red hair? Okay, so given that the student is a senior, this is my condition. Meaning I'm only going to look at the students who are seniors. I'm only focused on those 70 students. Then of those 70 students, what's the probability that someone has red hair? So that would be 0 out of my 70 students. Okay, that's a conditional relative frequency, a conditional probability, a conditional distribution. Okay, you're looking at only the group of people that meet some condition, and then based off of that condition, what's the probability of something happening? Okay, we can then use conditional relative frequencies to make segmented bar charts. And so a segmented bar chart, let me scoot these out of the way. A segmented bar chart would look something like this, where you have one bar, let's say for the juniors, and one bar for the seniors. This is divided up into their percentages. And then you would have different little bars in here, different little spaces in here to represent how it's broken up. Okay, this is a very bad example, but like, for example, maybe the top is black, this is the brunette, this is the blonde, and this is the redhead. Over here, we could have the blonde, the brunette, and then the black hair. And then by looking at these two bars, I can make a comparison to see whether or not there's a relationship between a student's grade level and their hair color. So if the bars are similar in how they're separated, then that would mean that there is no association between the two variables, because knowing that someone was a junior would not have any effect on whether or not they had, for example, red hair. In this case, because the bars are separated differently, then we would say that there is an association between grade level and hair color. So we will get into this in much more detail as we do our lesson for section 1.1. I just wanted to give you kind of an idea as to what these things actually look like numerically. And as we work on section 1.1, like I said, we will get into more detail. All right, thanks.